something is going up with a decreasing speed. And the question is, what is the direction of the net force? We look at the direction of the acceleration because from Newton's second law, we know that acceleration direction is the same as the net force direction. What about the acceleration direction? When the velocity is up, should that be the acceleration is also up? No, the answer is not necessarily. If it goes up with the increasing speed, direction of the acceleration is the same as the direction of the velocity. But if it goes up with a decreasing speed, the direction of the acceleration is opposite to the direction of the velocity. So now we know it is with a decreasing speed, therefore the acceleration direction is downward, therefore the net force is also downward. Okay, now I can go to the next question. Also statement question, a truck moves forward with a constant speed and has a crate in its cargo bed. If the truck suddenly speeds up and the crate does not move against the cargo bed, in what direction is the frictional force on the floor of the cargo bed exerts on the crate? Let me quickly draw some pictures. So this is the truck, and there is a crate, a box kept on the bed of the truck. So let's say it has a velocity of 100 kilometers per hour. Then suddenly the driver decides to speed up. It's coming with 100 kilometers per hour. The box is sitting on the bed of the truck. No problem. It is moving with the truck. Nothing happens to it. It will also have the same velocity, 100 kilometers per hour, same as the truck. Now let's say he put gas or increase the speed to 120 kilometer per hour. And you know from your experience what happens if you speed up, even as a passenger in the car or the driver in the car, you will, you are speeding, you will go back, right? You are speeding, then you will go back. Okay, why is that? Because the truck is being accelerated, okay, because it has been given a force by rotating the tire faster, but not you. You don't have any force. You are sitting on the seat. Okay, if there is friction will try to also give a force forward. So you also catch up with the truck. You are going with 100 kilometers per hour, but suddenly the truck is going at 120 kilometers. You have an additional 20 kilometer per hour is missing from you. So the force must be given to make you accelerate also at 100 to 120 kilometers per hour. That force has come from the friction between you and the seat, okay, or the back of the seat that is pushing you. But the crate is not sitting on there's no back support, right? It's not like you. There is no back support. Suppose you are sitting in a car with no back support and the friction is small, you will also go back. You'll be pushed back. But because of the back support, you are not. But suppose for this guy, it is not an option. He doesn't have a back support. And if there is no friction, he will go backward at a speed of 20 kilometers per hour backward. Why it is not happening? Because of the friction. What should be the direction of the friction? Because going backward, the direction of friction should be to keep him moving. So it should be forward. So the answer is the direction of the friction is forward. So I hope it is clear. Number 3. This is an easy, straightforward question, okay? Why? We have an equation, right? Net force. What is this equation called? Newton's second law. Second law. So he is asking, we are giving all the forces, giving the mass. The question is, find the acceleration. Can you do it in the calculator? Not yet. Why? Because this is not, it's a vector equation and in 2 dimensions, not in 1 dimension. So you need to add the forces correctly with the vector algebra. Anyway, I can still write this. Acceleration is equal to net force divided by mass. Net force means what? Sum of all the forces. You might say there are other forces, the the foot particle has a weight, yes, that is vertical, right? And it is balanced by the surface normal force, so they will cancel. So we only have to worry about the horizontal forces. Divide by the mass. The mass is given. The forces are given as vector, x component and y component. Even if you given the magnitude, you cannot substitute the magnitude there. You must add them vectorially. So you know how to add vectors, just use the knowledge. So you will say, I can add all the components and get the x component and the y component of the net force, divide by the mass. Mass is 0.70 kilogram. All you have to do is to now find the x component and the y component of the net force. And you know how to add vectors, right? To get the x component, you add all the x components and write it there. Simple addition. So these are the x component, minus 0.3, plus 0.3, that will make it 0. Plus 1, it will make it 1. So the x component is 1.0. Right. Y component, you add only the y components. So let's do it now. It's easy calculation. 0.4, all negative, right? So we can just add and put the negative at the end. 0.4, 0.3 is 0.7, 0.7, 0.01 is 0.71, but with the negative sign. Easy, straightforward. That's why I told you straightforward question, but the only complication is it's a vector addition, not normal addition. Right, now we are almost there. Now this is a scalar. So it has to be divided here, also divided here, then you simplify it. So it will be 1 divided by 0.71 and negative, don't forget the negative, okay, divide by 0.7, which gives you, I believe, A. Can someone check it for me? A, right? Yeah, answer. Why did you write by 71? Why did I write? Why did you write 71? Oh, sorry. Okay. Okay. Thank you. This is mass, right? It's not 0.71, 0.70. So you get the answer A? Right? Please check that. Okay. Right. Shall I go to the next? Good. Number 4. This is a statement question, but easy one. This is on Newton's third law. Now, you have to express the Newton's law correctly, okay? Don't say action reaction. That's not complete, okay? What is Newton's law? It is Newton's third law about two objects, objects 1, object 2. So what it says is, if object 1 exert a force on object 2, let's say this is object 1, this is object 2. If this one exert a force on object 2 is not going to stay put. It will exert a force on object 1 because you push me, I'll push you. So that force will be equal in magnitude what he gave, but in the opposite direction. That is the complete Newton's third law statement. So here is a question on Newton's third law. A box is being pushed by somebody's hand. Okay, his hand is, let's say, object number 1. And what is he pushing? Pushing the box. So box is the object number 2. So hand is pushing the box with a force F. So the force direction will be to the right, on the box. What will the box do? So object number 2 is the box will push the hand with the same force magnitude, but in the opposite direction. So now you completely understand. So which of the following statement is true? So if you read A and B, they both seems to be the same. Not really. What is the difference between A and B? It has nothing to do with this. Yeah, it's just a distraction. Yeah, it's just simple. Yeah, let me finish with him. Okay, you go. It's okay now. Yeah, yeah. The difference is A talk about the direction. B also looks correct, but it's not complete, right? Because the Newton's third law is not complete without telling about the direction as well. That's why A is the correct answer. Okay. So, it has nothing to do with the table, whether it has a friction, no friction, you don't care. Newton's third law simply saying we have to recognize the box is pushing by a hand. So the objects are the hand and the box. So if F is the force on the box will put a force on the hand, same magnitude, but opposite direction. Number 5. Right. So we have two objects connected together via pulley, which is a frictionless, massless pulley. So we can say the tension is the same on this string, and on this box, the big box, capital M, the direction of the tension will be like this. So first thing is to draw the free body diagram. The question, we have some values given, and finally to find the tension in the string. That's the question. No, it's not tension. It's the friction force, sorry. Okay. But anyway, we have to draw the free body diagram on each of the box, each of the object. So let me take the capital M. There's tension this direction, good. And it has a weight. The gravitational force will be mg. And there'll be normal force because touching the surface, there'll be a perpendicular normal force. And there is friction. So there'll be a parallel force as well between them. And that will be in the other direction because it's pushed this way. It is going to move to the right. So the friction force will be. Anyway, it is not moving. The question says it's not moving. But there's an attempt to move it, right? So there'll be a friction force in it. It's not moving. Why? Because of the friction force. It is keeping balanced. So we got the free body diagram for capital M. But anyway, because we may need this guy as well. Let's draw the free body diagram for small m as well. So that's complete now. Question is to find the friction force. Is there friction force on the small m? No. So we need to apply the equation for big M. We have no choice, okay, because there only we have the friction force. So let me apply the Newton's second law in the x direction because we choose this as my x direction. This will be the y direction. So N and mg are all in the vertical direction, so it will not contribute anything in the x direction. So T will be there. It is plus. T is the magnitude of the tension. So since it is to the right, I'm choosing the positive x to the right. So it will be plus T, and friction force in the negative x direction. So I'll put negative F equals mass. Mass is capital M, right? Because that is the box, big box. And A is 0 because the question says it is not moving. So friction is equal tension, but we don't know the tension. Two unknowns, both of them are unknowns. So looks like we cannot solve the problem. Not really, right? Because the tension is the same tension on the small box also, small block also. Maybe I can solve the tension from the small block and bring the value here and complete the question. So let me go to the small m. Here it is only in the y direction, in the x direction, because again, I'm going to take this as x direction, this as y direction. So in the y direction, I'll apply the equation. Plus t minus mg equal to small m, okay. Multiply acceleration is 0, it's not moving, none of them is moving. So from this, I can find the mg, t. So it will be equal to 3 multiplied by 9.8, which is equal to, somebody help me? I believe it is 39.2. It's close to 40. Anything that is close to 40 is 49. Okay, I think it is 9.8 multiplied by 10 will be 40. So multiply 9.8 must be 39.2. Somebody can check. Okay. So we got the tension. Yeah. Yes. If it moves, unless the acceleration is given, we will not be able to answer it, right? Yeah. Moving with a certain acceleration, you give me the value of the acceleration, then I can solve. Okay. Good. So the answer is B. Number 6. Again, two bodies connected via a string, but it's something like this called active machine. This kind of setup as a name. M1, M2. M1 is given, M2 is not given. Acceleration is given. Question is the tension. So again, because of massless, frictionless pulley, the tension is the same here as well as there. The tension, there will be a tension on M1 and tension on M2. I mean, then we have this, because if there is a friction in the pulley, tension may not be the same, but we say it's a frictionless, massless string. Do we say that anywhere? Well, massless string. Strictly speak, ideal pulley. Okay, ideal pulley mean frictionless, massless. Right, now what? Apply the Newton's second law. The question is to find the tension, then you can either apply on M1 or M2. Tension is there in both places. But what should I do? What do you suggest? M1. Why? Yeah, M2 is not given. So there will have an equation with two unknowns. So naturally, you will go to M1. Net force equal to mass into acceleration. So I'm here, let me take this as y, this as x. So in the y direction, because in the x direction we do not have any forces, so no point in applying anything there, plus t minus m1g, that is the net force in the y direction, equal to mass multiplied by acceleration, is given 6.1 is given. I will not substitute anything now, I'll put a. Okay, a is the magnitude of the acceleration. T stands for the magnitude of the tension. M, of course, I did something wrong. Okay, it's very careful. Okay, suppose then later on you don't know whether to put the M1 or M2. I wrote the equation for M1. G is the magnitude of the acceleration, which is gravitational acceleration, 9.8. Not the acceleration of the block. Acceleration of the block is something else. G is just you are getting mg is G is the gravitational acceleration. Right, now all you have to do is to substitute and find the tension. You can do algebra if you want. It's not a difficult algebra, right? So just do it. You to that side. Then you can do the calculation in the normal way. But however, you can ignore the algebra. You just write the equation in your calculator. Yeah. Yeah. I'm looking, this equation is for M1. M1 is going up with an acceleration of 6.1. So what you should is, I didn't put negative a, I put only a. Okay, a stands for the magnitude, so I should put the plus a. So that means no. They are moving. While this is moving up, M2 will be moving down. So the acceleration for the M2 is negative 6.8. Acceleration for M1 is positive 6.1. Okay, the way we choose on the y positive direction to be upward. Okay, did I answer you? Okay. Both of them moving together. The string is always at tension. That means the acceleration magnitude is the same for M1 and M2. Okay, right. So we can take the calculator. You don't worry about the algebra. Let the calculator solve it for you. So what do you do here for t? I'm going to use this one, okay? This you can do it, okay? Where is my calculator? T, you will call it x. Alpha, right bracket, so you got the x. Subtract m1. M1 is 3. Multiply by 9.8. That's the magnitude of the acceleration. Do I press the equal sign? No. The symbol, right? So alpha calc, the equal. Again, 3 multiplied by A. A is plus 6.1. So I can just type 6.1. Because I'm writing the equation on M1 and M1 is going up. So the acceleration is positive. What do you do now? Solve it. Tell the calculator to solve it for you. Shift calc. Is this the answer? No. This is what was in the memory from a previous calculation somebody did, memory of x. So what are you supposed to do? The next step is, the final step is to click the equal button there. Excuse me, please. So now if you see x equal to, that means it has calculated. L minus R is comparing verifying the answer. 47.7. So B is the answer. Right, now we can go to the next question. Number 7. It is reported that when a 45, if you want to talk, please go outside of the classroom. If you have a question, raise your hand and ask me. It is reported that when a 45 kilogram person stepped on a scale in a moving elevator, the scale read a steady 300 Newton. You know about this question, right? I mean, is Newton's second law applied for a person standing on an elevator? So what is it? Say you scan a scale. So when he stands, what does the scale read? Scale read is actual weight or how much he is pressing on it. It reads how much he is pressing on it. You mean the N, the contact perpendicular surface force. That's what it's measuring, right? So that you should understand. Now I can apply the Newton's second law for this person. And the N comes here, that is what is being pressed. So that will give me N minus mg is equal to ma. So I can even write it as N equal to, because I'm worried about the N. So N is, I can call it elevator equation. Is this equation going to come in the formula sheet? No. What will be in the formula sheet is the Newton's second law. If you want, you can memorize it. So you know this is the equation that I can use for the elevator question. But even if you forget, you know how to get it, right? From the Newton's second law. Here we assume what is the positive direction, and I got this equation. Up is the positive direction. N is the magnitude, mg or magnitude, a is also the magnitude of the acceleration. So now you can see why the scale is sometime not going to give the actual weight, because scale only measures N, how much you are pressing on it. Okay, now let's go and read the question again. The M of the person is 45 kilogram, but the scale is reading 300 Newton. Scale is supposed to read what? If everything is as usual, the scale is supposed to give the actual weight, right? Actual weight is, M is how much? 45, and G is 9.8. Someone calculate this, 441. But the scale is reading 300. So you know something is going on. It's a moving elevator, right? So it might have an acceleration. If the acceleration is 0, what the scale read is, should be reading 441 Newton. Because the acceleration is not 0, because the elevator is moving, that's why we have this situation. So acceleration is positive or negative? Is it upward or downward? Yeah. Huh? Okay, let me ask this. Is the acceleration positive or negative? Negative. Why? I am getting something got subtracted. That means acceleration is negative. That's why, although it is supposed to read 441, it is reading 300. So ME must be negative. That means acceleration is negative. Negative means what? Its direction is downward. Okay. So I'm going to pause here. I want to sink this in to you. Okay. So if someone asks you why, if someone asks you, wait, never mind. So you know acceleration is negative. So since our convention is up is positive, down is negative for this equation to be valid, so your conclusion is the acceleration is downward. Negative mean downward, right? Negative here mean downward. Right. So we give this problem to some students, student A, student B, and student C, and ask their opinion. Student A says, okay, I know why this is happening, why you are not measuring the weight correctly, because he's saying elevator is moving up with a decreasing speed. Is she correct? No. No or yes? You want the acceleration to be negative, right? That means you want the acceleration to be downward. His statement, elevator is going up with the decreasing speed. What is the direction of the acceleration? Down. So she is correct. Okay. Student A, he can be correct. Okay, because there are other scenario also. Cannot say she is the only correct. Okay, she is correct. But there can be another opinion. Let's look at the other opinion. So she is correct. Yeah, she can be correct. But that's not maybe not the only solution, only scenario. Student B is moving at a upward again at a constant speed. No. Why? No. Acceleration is constant speed means acceleration is zero. It doesn't matter whether moving up or down. You can move up with a constant speed. You can also move down with a constant speed. Right? Acceleration is zero. So he is wrong. Student C is also wrong, because in both cases we get the acceleration to be zero. I want acceleration to be negative. So student A is correct. Okay, but may not be only correct answer, but he is correct. Okay, what is the other answer? It could be correct. Going down with increasing speed. Suppose there's another student D who says it is going down with increasing speed, because when the increasing speed mean acceleration direction also same as the velocity direction. So if it is down, that means acceleration is also down if it is increasing speed. But that choice is not there. So in this choices, only student A is correct. Therefore, the correct answer is A. Can be correct. But student B can be correct? No. Student C can be correct? No. Both of student A and B can be correct? No. Okay, one is correct, one is wrong. So that is wrong. Both student A and B can be correct? Is the same answer? B, A, and C. Okay, right. So you know why A is the answer. Student A is question 8. It's a straightforward question. Okay, a car is describing a horizontal circle. Let me draw the car. Let's say this is the center of the circle. So it is going. Imagine, okay, this is section. So it is going like that. So this force N and this force mg, they are both vertical forces, right? If something going in a circle, you need a force toward the center of the circle, because there's an acceleration toward the center of the circle. So that means there cannot be acceleration without a force. There must be a net force in the direction toward the center of the circle. Though that is horizontal, right? Acceleration is a horizontal. So net force must be horizontal. Can the normal force contribute to the acceleration? No, it has zero component. Can the weight contribute to the acceleration? No, it is also perpendicular to the horizontal direction. So who is giving the force? If it is not the surface force, normal force, perpendicular surface force, if it is not the gravitational force, friction. Friction is the between the floor and the tire of the car, the parallel force, right? So it's a friction which has to be in this direction, which will give the necessary centripetal force. So we apply the Newton's second law. Net force is equal to mass into acceleration. The force is only the friction because in that direction, we are looking at that direction, equal to mass of the car multiply acceleration of the car. Now you need to remember something else. What is that? Centripetal force magnitude. It is given in the formula sheet. So it can be given in terms of the speed and the radius of the circle. That's it. We got the equation. All you need to substitute. And it says, you don't even need to do solving because this is the question and it is the subject of the equation. So you just substitute. 10,000 is the mass. Multiply by V is, oh, no. I'm sorry. So this is given, this is given, this is given. The question is to find the, not the friction force. Question is, so maybe we can better use the calculator. Of course, you can do the algebra. Can you do the algebra? How would you? I will do the algebra, but I will do the calculation with the calculator. How would you make the V square? Okay, V square, move things around. So FR divide by M. With practice, you can do it very fast, okay? But you don't have to because you can use the calculator. Then take the square root. You can do that and you can do the normal calculation, fine. But why bother? You have the calculator, you're allowed to bring your calculator. Take the calculator, clear everything. F is how much? 10,000. And alpha, that will be the equal sign. Then you, M, how much is M? 2,500. Multiply by, you use the fraction, so you can put up and down. V squared, what will you do? V, we don't know. You'll call it X. How do you get the X? Alpha, this, and square it. Don't forget the square, okay? Then you come down, 64. Make sure everything is in SI unit, okay? This is also important. Suppose the radius is given in centimeter, you better convert it into meter, but it is given in meters. Everything is good, everything in SI unit. What do you do next? Tell the calculator to solve it. You don't have to do all this algebra. You will save time. It's also calculator will do it precisely, provided you know how to use the calculator and provided you didn't make any mistake. So that's why it is important when you come to the exam, you should be alert, concentrating, should have a nice good night's sleeps before, okay? Right, so how do you do that? Shift, calc. Is this the answer? No. This is what you got from the previous calculation. Of course, you remember that. We did that previously. Okay, anyway, no mind. We have to do one more step, which is the pressing the equal button here. 16, okay? You'll get the same answer if you do that direct like that. Should supposed to check it. Right, question number 9. So this is a center of mass question. It's also a straightforward question. Okay, we have a model. The person is standing. Then we take the head as a segment and we break into pieces, segments. Torso, you know what is torso? The hands and the leg. So here in this table, you made it very neat and nice. So you don't have to read too much. If the table is there, everything is very clear. So the head, its mass is this much. And the center of mass of the head, it is somewhere here. it's given as X center of mass is this, Y center of mass is that. And the torso, which is this part, its mass separately alone is 50.1, is X center of mass and its Y center of mass, maybe somewhere here. It's all given to you. So you break it into pieces, okay? Then ask you to calculate the center of mass of the whole person. We have an equation, right? What is the equation? It's in the formula sheet. X center of mass is equal to, now they are broken into 4 pieces. So there'll be M1. M1 is the head. M2 take as the torso. M3 is the lower arms. It should be the whole arms. You don't only have the lower arms, right? The whole arm. Anyway, M1. Arms, that one, and legs. So the equation is sigma mi xi divided by the total mass. So that will be what? X center of mass. He's asking for X center of mass. Okay, be careful. Read the question. Maybe we'll be asking for Y center of mass. But here it is asking for X center of mass. So you have to go to only the X coordinates of each. So it will be M1 x1 plus m2 x2 plus m3 x3 plus m4 x4. Divide by what? Only m's. m1 plus m2 plus m3 plus m4. I mean, you may complain, oh, it's too much calculation, I will make a mistake. No, you have a calculator. You can write the expression. It's not solving equation because the subject is this question. So take your calculator, but you have to be careful again, okay? You should be alert, not make any mistakes. It's an expression to calculate. So use the fraction, and you have the table very clearly. So what should I do? What is M1? 8.1. Multiply by, is it 0.1 or 1.9? 0.1, X center of mass. So these are all extra data. Plus, do I have to put the bracket? No need. Okay, if you are worried, you can put the bracket, but we know there's a precedence of operation. First it will do the multiplication, then only it will do the addition. Okay, so you don't have to. So why waste the time? Plus M2, 50. Please make sure I'm not making mistake, okay? So you're watching the screen. 50.1 multiplied by 0.1. Plus, thank you, 4.6 multiplied by 0.4. So far, so good, right? Didn't make any mistake, right? Plus 31 multiplied by, again, 0.1. Now you come bring it down. Now you put all the masses, add them. So it will be 8.1 plus 50.1 plus 4.6 plus 31. Okay. Check again that you didn't make any mistake. This is not solving. It is just press the equal button. There is no equal sign here. Okay. Just the expression. I wrote it as an expression. Press the equal button. Well, this is still as a fraction. Press this SD button. Okay. I don't know why it is showing like that, because we're repeating. 0.1147, okay? So what's the answer? C, right? 2 significant digits, it is, I believe. It's also a straightforward question, okay? Although, well, the only thing is we have a vector, okay? So what is momentum? You should know the equation for momentum. Mass multiplied by velocity, straightforward question, definition question. Mass is 2 kilograms. And velocity is 2 components, right? So you cannot say, okay, velocity is 3 plus 4, 7. 7 into 2 is 14. Is that there? Yeah. Okay. Wrong answer. All right. So you have to do like this. 3, 4. So it will be 6. Yeah, you can do that too. But anyway, 6 and 8. So this is the In the vector form, momentum is equal to x component is 6, y component is 8. But he is asking for the magnitude of the momentum. You know how to get the magnitude of a vector? X component squared plus y component squared. So momentum magnitude will be which will be 36, right? Square root of 36 is 6. Did he say 36? Did I make a mistake? 100. Why did you say 36? Without doing the calculation, you just mental calculation. 100, right? Okay, square root of 100 is 10. Yeah. Yeah, yeah. You mean you take the magnitude of this, which is 5, and 5 into 2 is 10. That's what I want to do, but I have to explain things. Okay, but anyway, it's like saying magnitude of momentum is equal to mass is a scalar anyway. Mass multiplied by magnitude of the velocity. The Pythagoras triplet. So probably that's it. So magnitude of velocity is 5. 5 into 2 is 10. The physical quantity, I don't know if I'm recording or not. I'm having doubt. Yeah, I am. Right, the physical, that's easy, right? You know that. Okay. We have this equation, impulse. The definition of impulse is F delta T. That's the definition. Then we use the Newton's second law and we get this. Momentum is, this is called the impulse momentum theorem. So whatever the units dimension of momentum, it will also be the dimension of impulse. Number 12. In an isolated system with two moving objects, when collision occurs between the objects, it's an isolated system, so no work done from outside, everything is inside. So there is no forces active from outside. Then we know the momentum is conserved in an isolated system. What about in the collision? Can you say the same thing? The kinetic energy is also the concern? No. Not always. We don't know. I mean, it might, become heat and maybe it will stay inside, but it's still the collision does not conserve, not necessarily conserve the kinetic energy. Bounce back doesn't mean it has conserved the kinetic energy. So that means the answer is C. Only the total momentum conserved. I said two questions, right? Shall I do one more? You say yes, I will do. If you say no, I will not do. Yes, okay. A 0.14 kilogram baseball is dropped and reaches a speed of 1.20 meter per second just before it hits the ground and bounces. It rebounds with an upward velocity of 1.00 meter per second. What is the change of the ball's momentum during the bounce? Yeah. So we will take, because we need to make it mathematical, so we have to take some direction to be positive. Let me say the upward direction to be the positive direction. So that means if you get a positive answer, it is upward. If you get a negative answer, it is downward. So we have to stick to this. So change in the momentum, delta P, is equal to P final minus P initial. It's a vector equation. So mass multiplied by V final, because momentum is mass into velocity, V initial. Right, now let's substitute values. M is what? 0.140. It's a magnitude. But these are vectors. V final is 1 plus or minus. Why minus? Is going up, right? Final velocity is after bouncing. Initial velocity is before bouncing. After bouncing, it is going up. So it is +1. Minus, now V initial. What about V initial? It is negative, and the value is 1.2. Oh, I'm sorry. I have to put value, but you have to put the sign also, right? Is equal to minus 1.2. Okay, good. So now you do the calculation. We can do it in your head, right? So 0.140. 1 minus minus will become what? Positive. So 1 plus 1.2 is 2.2. Now we have a positive answer. What is this equal to? 0.14 multiplied by 2.2? 0.308 with a positive sign. So we can, this is an answer and this is an answer, either A or D. Which is correct? D, because the sign is positive. So it is, change is positive. Right. I will stop. Yeah. Which one? In the same year or another one? Okay, question number? The one I already solved, you want to go back again? Oh, okay, good. Question 16. Very good. Yeah, okay, good you asked me. Okay, because some people have confusion still. Right. So we have a rod and it is pivoted in different places. You have to pay attention to that. In A, the fulcrum where it is pivoted is here. In B, where it is pivoted here. In C, where it is pivoted here, and D. Okay, maybe that is the most common mistake I saw. People don't realize that you have to pay attention to that. And the same forces applied, I mean, at the same location, it is applied in all A, B, C, D, E. And we have the freedom of changing the magnitude only. You can change the magnitude of the force. You cannot change the location. You cannot change the direction. Also, when you change the magnitude, you cannot make it to 0. As long as anything other than 0, fine. Right. So he is asking which one is in equilibrium. Okay, rotational equilibrium, because it's fixed. It cannot go anywhere. Rotational equilibrium, which cannot be in equilibrium, which cannot be made to equilibrium. So the point here is we look at the torque from each of the force other than the force at the pivot point, because we don't care, because the torque from the pivot point at the pivot point will be 0 anyway. So the other forces, you should have at least one positive torque and one negative torque. Are you with me? One positive torque and one negative torque. The moment you find one positive torque and one negative torque, you can say this can be brought to equilibrium because I can adjust the values of the torque. So the positive amount is equal to the negative amount, because you have the freedom of adjusting it without making it 0. So let me start with A. So what is the torque from this guy? 0. Any objection to that? No. What is the torque from this guy? Negative. Any issue with that? How do you look at it? Always pay attention to the fulcrum, okay, the pivot point. So you are pushing with like this, it is rotating clockwise, so negative. This one, positive. This one, why is it 0? No, R is not 0. Angle is 180. No, not 180. Angle is 0. So sine 0 is 0. Therefore, so you anyway we are already done. We have one negative and one positive. So this can be brought to equilibrium. So he is out. Let's look at this guy. I will start with this one. Now what is the direction of the torque? It is not 0, right? There is an R. So it will be positive or negative? Positive. What about this guy? Negative. Here, the same guy, yeah, it's still negative. Okay, fine. I will come. Is it okay? Everyone is fine with that? And this one is positive. Because this is the fulcrum, this is trying to rotate it counterclockwise, this one is trying to rotate it clockwise. What about this guy? Positive. And what about, again, we are already there, right? We have one negative, one positive, so he cannot be in equilibrium. See, this one is, I'll start with this, positive. This is 0, this is 0. Both of them are 0 because R is 0. The point of application of the force and where the fulcrum is in the same place. Yeah. Okay, right. Let's do with this, right? Okay, the fulcrum is here. The force is here. Let me start with force. So I am pivoting it here. Somebody is holding it there. And I am pulling like this. Which direction it is rotating? Counterclockwise. So counterclockwise rotation is positive. Clockwise rotation is negative. Good? Not all of them for this particular one. Yeah, everyone you have to look at it fresh. Yeah, if it counterclockwise is positive, clockwise is negative. Right. And we got 1 plus. This is also 0. What is the condition? At least 1 negative and 1 positive. No matter what you do with the sizes, you can never bring it to equilibrium. Because we don't have a negative torque. We only have 1 positive torque, no negative torque at all. I think now let me do it very quickly. So what about this one? Positive. This one, positive. This one, negative. This one, 0. So you have 1 positive, 1 negative. So it's all right, I will stop. You're welcome. Yeah. The answer is C.